Hello, and welcome once again to my channel. In today's lesson, I want to continue with parallel lines in geometry. So the question we want to ask ourselves is, what are parallel lines? Now, parallel lines are lines in a plane that do not meet. That is, two straight lines in a plane that do not intersect at any point. And that's what we call the parallel lines. So we have these two lines here. If you look at these two lines, they are parallel because they will never, ever meet. Now, when you consider two parallel lines, the distance between the two lines, that is, if you take a line perpendicular to this, a line perpendicular to each of the lines, you have equal distance between the two lines. Okay. Also, we can look at parallel lines in terms of slopes. So let's determine the slope of this first line here. What will be the slope? So the slope will be the rise over the run. So let me draw a line here and there. So the slope of this first line here, the slope will be equal to the change in the y, which we write as delta y over delta x, all right, the change or the rise over the run. So what's the rise here? The rise between these 2 points will be 1, 2. So 2 up, and then horizontally, the horizontal distance between 2 points here, you have 1, 2, 3, 4, right? So 1, 2, 3, 4, 5. So 5 boxes or 5 units between those 2 points. So 5. So you have 2 over 5 as the slope. Now, what's the slope of the second line here? The slope of the second line will be the rise over the run. So let's draw another line from here. These 2 points and these 2 points here. You always need 2 points to be able to determine the slope. So between these 2 points, the rise here is 2 units, 1, 2. You have 2 units, and the run, the horizontal distance between the 2 points. You have 1, 2, 3, 4, 5. So 5 spaces, 1, 2, 3, 4, 5. 5 units between the 2 points. So that's a change in the x values, okay, 2 over 5. So if you look at the slopes, we have the same slope. So parallel lines have the same slope. Same slopes. Okay. So these are some of the features of a parallel line. They'll never meet. Equal distance between the two lines, and then they have the same slopes. A line that cuts through parallel lines is what we call a transversal. So we have these two parallel lines. Let's call that L1 and L2. This line that is crossing these two lines, intersecting the two lines, is what we call a transversal. Okay, that's a transversal. Now the transversal gives the parallel line some properties or identities. And we're going to look at some of them, okay? This transversal here, so let's label that the transversal. As we can see, it's producing several angles as it intersects the parallel lines K and L. Okay. So there are some names for these angles. Let's begin by looking at some of them. So the first angle that we're going to look at is known as the corresponding angles. Okay. So what are the corresponding angles here? Now, these are angles that occur at the same positions when you compare them. So let's look at some of these angles. If I take angle number 2, okay, this angle number 2, this angle, if you look at angle 6, they're in similar positions. So we refer to them as corresponding angles, all right? So let's give an example, angle 2 and 6, angle 6, corresponding angles. I can identify other corresponding angles. Let's look at another one. If I take angle 1 and angle 5, the relative positions are the same. So angle 1 and 5 are corresponding angles. I can identify more. Let's try another one. If I take angle 4 and angle 8, they are corresponding angles. Angle 4 and angle 8 corresponding. I can identify another one. If I take angle 3 and angle 7, they are corresponding angles. So relative positions are the same. Those are corresponding angles. All the corresponding angles are the same. So we say they are congruent. So, corresponding angles are congruent. That means same or equal. Okay. So if this angle is 60, that one will be 60, 70, 70, and so on. Now let's look at identify some other angles. The other angle we're going to look at will be the alternate angles. So let's look at the alternate angles. What are alternate angles? They are angles that occur on either side of the transversal. Okay. And there are two types that we're going to look at. The first type will be the alternate interior angles. Okay. When you say interior angles, the interior angles are the angles between the parallel lines. So angles that lie between the two parallel lines are interior angles. Okay. Okay. Or interior angles. And all angles outside, all those on the outside here, outside of the parallel line, those are exterior angles. Okay, the outside the parallel lines. Okay. So when you talk about alternate interior angles, the angles that we are looking at will be the angles between the two lines. So let's identify the alternate interior angles. Okay. If I take angle 4, interior, and then angle 6, those are the interior angles, right? But because they are on either side of the transversal, we say they are alternate angles. So angle 4 and 6 are alternate interior angles. Right. And then if I take angle 3 and angle 5, angle 3 and angle 5, okay, they are between the two lines, parallel lines, so they're interior, but they're on either side of the transversal. So those are also interior alternate angles. Now we can also look at the alternate exterior angles. If we take angle 2, it's on outside the exterior, and then angle 8, 2 and angle 8, they are on either side of the transversal and the outside. So those are alternate exterior angles. Angle 2 and angle 8. Also, we can say that angle 1 and angle 7, they are alternate exterior angles. Okay. Angle 1 and angle 7, alternate exterior angles. Now, the alternate angles are all congruent, okay? So you see that the alternate interior angles are congruent or same. alternate exterior angles are also congruent or the same. So you need these properties to be able to answer questions involving angles in the parallel line. Okay. Now, some other angles that we can also identify on the parallel lines will be the opposite angles. Or what we call the vertical angles. So let's try vertical angles. Okay. So what are the vertical angles? Anytime you have two lines that intersect, you form vertical angles. So the angle here, it's the same as the angle on the opposite side, right? Angle here, same as the angle there, called vertical angles. So when we take our diagram, it means that angle 1 and angle 3 directly opposite to each other, right? At the point of intersection. So those are vertical angles. Angle 1 and angle 3. Also, angle 2, angle 4, they're vertical angles. Okay, when we come to the other side, line I, we can have the same thing. Angle 5, angle 7. Opposites or vertical angles. Angle 6, angle 8, vertical angles. Okay. Now, the pair of vertical angles are equal. Or congruent. Okay. So 1 will be the same as 3, 2 same as 4, angle 5 same as angle 7, angle 6 same as angle 8, and so on. Okay. Now the last type of angles that we're going to look at will be the linear pairs. We call the linear pairs. Okay. So the linear pairs are angles on a straight line. So if I take a straight line, this angle here and the angle on this side, they form a linear pair. So linear pairs always add up to 180. So their angles, the angles are on a straight line. Okay, and they add up to 180 degrees. Okay, that's what makes a linear pair. Okay. So what are the linear pairs here? Angle 1, angle 2, linear pairs. Angle 4 and 3, linear pairs. Another one, angle 5 and 6, linear pairs. And the last one here will be angle 5, angle 8 and 7. Angle 8 and angle 7. They also form a linear pair. Okay. So that is what is illustrated in this diagram here. Okay. The linear pairs, the blue and the yellow, they add up to 180 degrees. Okay. So with this in mind, let's practice on some few questions. Let's assume that I have two parallel lines and it's a transversal. If this angle is 60, let's find this angle X. What will angle X be? What is going to be angle Y? We can find that. What will be angle Z? What will be angle A? Let's call this angle B. Angle C, angle D. Okay. We can use the information that we just studied to answer these questions. So let's begin with this part here. So for angle Y, we know that this will be equal to 60 degrees, okay, because directly opposite, these are the two lines intersecting here. So because the two lines in the transversal and the parallel intersect here. So at this point, we've created vertical angles, right? So since this is 60 degrees, Y will be 60 degrees, okay? And the reason it's vertical angles. That'll be the reason. So let's put this right 60 here. Now what will be X? If I take X, right, and the 60, the X and 60 here, they lie on a straight line, a straight line. So it means that they are linear pairs, right? Linear pairs add up to 180. So to find X, X will be 180 minus 60 degrees. So that gives us 120 degrees. So those are linear pairs. Add up to 160 degrees. Sorry, I said 180 degrees. So let's put this here. So 120 degrees here. So if X is 120 degrees, what will be Z? Take 30 seconds to tell me the answer. All right, so Z and X, you see that at the point of intersection, so directly opposite to each other. So that means that X should be the same as Y. It's congruent to X, to Z, right? Congruent to Z, directly opposite. So they are vertical angles. So Z will be equal to 120 as well, 120 degrees. And the reason, vertical angles. So this is 120 degrees. All right, so all the angles at this point of intersection. Now let's go to A. What will be the angle A? If you look at angle A, angle Y, and angle A, they are related by interior alternate angles, right? That's the relationship. So interior alternate angles, they are congruent, they're the same. So it means that angle A is equal to angle Y. So that would be 60 degrees as well. So alternate interior angles are congruent. So I'm going to write 60 degrees here. We can find B. What will be B? There are two ways we can find B here. If I know that this is 120, so this is X and Z is 120. Now Z and B are related by alternate interior angles, all right? So B should also be 120 degrees. Relationship is alternate interior angles. They're congruent. Okay. I could also have used the fact that these two angles (60) here, right? A 60. So I have A and B. A and B here, they form linear pairs. They're on a straight line, they lie on a straight line. So they form linear pairs. So if I subtract 60 from 180, I'll get 120 here, right? So it's the same thing. I could have used that reason. So either linear pairs or use the alternate interior angles. If I know that this is 120, B and D, they are related by vertical angles. So B and D, vertical angles. So it means that they're also congruent. So D will be equal to 120 as well. Vertical angles. Okay. So let's put 120 here. And then C, I can say that A and C are vertical angles. So A and C are vertical angles. So they should also be congruent. So that means that's going to be 60. C is going to be 60 degrees. Okay. So vertical angles. I could also have looked at this in terms of linear pairs, C and D, linear pairs. So if this is 120, if I subtract from 180, I'll get C. All right. So these are how you can use the different properties to answer questions on parallel lines. Okay.